session. I would like to thank XCOM Labs. Thank you, Paul Jacobs. Thank you, Dev, for being here with us today. We look forward to your presentation. And yeah, I think we have a good size of people now in here. So yes, please go ahead and get started. We look forward to your presentation, Paul. Thank you so much.
Great. Well, thank you for having me, and good morning. And I see there's somebody in Ireland, so good afternoon to you. Yeah, happy to talk to you about augmented and virtual reality, or the way we like it, XR from XCOM. But really, this notion of taking the physical and the virtual together and creating more immersion and interactivity, and just providing a more real experience. So if you can go to the next slide, just start off by just talking a little bit about XCOM itself. It's a company that we founded in June of 2018, and we're focused on building wireless infrastructure. We have wireless multimedia, and it's I founded it with two partners, former executives at Qualcomm, and we've worked together for like 30 years. So if Matt Grob, who's our CTO, if I want to give you a sense of how long ago it's been that we first started working together, we worked together on doing fax over CDMA networks. Derek Aberle was president of Qualcomm. He was the guy who did a lot of the licensing negotiations with the Chinese government back in the day when Qualcomm was having its issues there. And really, it's XCOM Labs was created by a group of people who, like I said, we've been working together for a very long time. And we love the phrase, the best way to predict the future is to invent it, because we were able to do that a few times at Qualcomm. And so our catchphrase at XCOM Labs is to keep inventing. And the things that we're inventing right now are next generation mobile technologies. And as we did the various G transitions at Qualcomm, we always had a sort of a canonical application that was the one that drove the system design specs. And in the case of XCOM, we focused in on augmented and virtual reality and real-time video, because these require high throughput, low latency, high reliability, very difficult design specs. And these were all attributes that people said 5G was going to give, but in reality, 5G is still working at providing those. So we said, okay, we're gonna provide those, and we're gonna build the systems to do that. And so we have three main projects, and the two of them are wireless systems, and one is multimedia software. The first, we have a 60 gigahertz system. It's obviously unlicensed band technology, covers about the size of a basketball court system, but it has guaranteed latency, which is roughly like a wire. It's not much more than the latency you'd get over a wire. And very high reliability. So one of the issues in 60 gigahertz was that you have blocking. We deal with that, and we eliminate that. So it's very highly reliable, throughputs of 250 to 400 megabits per second per user, with say 60 users in a 30 by 30 space. So it's a very high capacity system. High throughput, very high reliability. And while we were doing that, working on that technology, we realized that we needed to build the end-to-end system. So we built this Excalibur split rendering software. I'll talk a little bit more about that later. But it came from an early thing in the company, an early project that we did with Facebook, now Meta, on Facebook Live from the Sacramento Kings arena, where they wanted to have fans watch on their phones a video, and then be able to respond to it, put out emojis and so forth. And the issue was that fans were sitting in the arena, so they were watching the game live, but they were also seeing it on their screen. And what we ended up finding out was there was so much latency in various places in the system. People put buffers everywhere in the system, and then it got to the point where while you were watching the game on the phone, you'd see the players at one end of the court when they were in reality at the other end of the court. And so we came to realize that, if you don't really optimize end to end for a system which requires high performance and in particular low latency, you're going to get in trouble because people are going to put buffers into various places and wreck the experience essentially. So we built this split rendering software so we could control the stack, not all the way through the content. We're not doing the content, but we're building all of the rest of it to make sure that that experience is very good. And then we also built a 5G system. So it's a system with a very high capacity. It's a new technology. We haven't really launched it fully yet. It's still a little bit stealth, but just as an example, when we went from 3G to 5G, in terms of efficiency, we really only got a few tens of % of improvement in efficiency, and the throughput increases came from going to using more spectrum. This thing is like 6 to 10x, so not percents, but 6 to 10 times. And that then allows you to do things like augmented and virtual reality and walk around over large areas, and a fully standards compliant thing. And we've been doing this technology with from our office in San Diego. We're just opening an office in India. We have about 90 employees right now. Next slide. So we were fortunate because we chose XR and VR as our application, and then along comes Meta and Mark Zuckerberg and makes the metaverse much more well known. So not necessarily that it's flipped into fully mainstream yet, but it's on the way. And then the analysts come out and say, hey, there's this massive total addressable market. So it looked like we chose a good set of applications to go after, and you can see the various things. I'll talk a little bit more about this later too, is kind of retail and consumer, product and service development, healthcare, development and training, process improvement, but 1.5 trillion. I mean, it's a number that sort of catches your attention. So okay, there's this great market. Next slide. But there's barriers to adoption, and obviously our key goal here is to make it more real, to increase the immersion of it, and these barriers are things like, are you alone in the system? Is it just you, or are you able to interact with other people? We all know plenty of experience now of hybrid meetings, hybrid work. Somehow we want to make a hybrid between kind of in real life, in virtual life, to be in mixed life, in an extended reality experience. We also have seen that high quality AR and VR in the past has been tethered or required you to carry a relatively heavy backpack to have compute, and you really want to not do that. You want to be able to wander through these virtual reality spaces. And I can tell you, when we went from a smaller lab to a much larger space, and you were able to take many, many steps in virtual reality, the qualitative immersion that you got was really dramatic. It really became much, much better. So being able to walk around and not have the images rush at you makes it also more comfortable, so you don't get motion sickness as well. And its motion sickness comes about also because of latency. So you need to manage the latency very carefully in the system. When we had visitors coming to us at XCOM Labs to try the system, we had AR and VR demonstrations, and many people wouldn't put on the VR headsets at first because they said they got sick. And we said, no, try our system, because we've managed the latency very, very carefully. And so it's very low. And lo and behold, they don't get sick using the system, because you absolutely need to do that. And then the other thing about mobile XR, we want to cut the link, but now if you're just using the compute that's in the headset, which by the way is tremendous amount of compute, because we did that at Qualcomm. We put a lot of capability into a smartphone chipset, but it still isn't this what you can do on a server on the edge. And so by splitting the rendering between the headset and servers on the edge, you can really give a ton of compute. And the headset's going to have a hard time keeping up with that much compute for the amount of power that you can spend, for the size, for the heat generated. And then, if you want mass data sets or massive numbers of users, then the edge is really the place where you want to go. And so what we're trying to do here is like what we did in the 90s and 2000s when we were trying to build the foundations for the wireless internet, which went mainstream when the iPhone came out. Here, we're also trying to build the foundations for XR and get ready for when the user devices are closer to, you know, our glasses or the science fiction world that we all want to be in. So, next slide. So what did we end up building? We ended up building this wireless XR. It's multi-user. It's completely photorealistic. The system, as I said, it's completely end-to-end. So all the way from the rendering out to what goes onto the device and the wireless system in between and the multimedia software. And it's basically, if you support Stream VR, our system just works. And you can put many people into the same space. We're talking in the 60 gigahertz system, as I said, it's tens of people. But in the 5G one, we're talking about even more people. And certainly when you use things like AR, which use less throughput, then you can put significantly more people onto these systems. So the other thing is, you know, it's completely seamless mobility. It's you know, there's no backpacks. It's, you know, the backpack when we first started out working with the Void, it was 22 pounds of equipment. Now it's just the headset. Latency is, you know, managed, as I said. So late frames are lost frames, so you can't have late frames coming. It's high throughput and so forth. You can see, but the notion is, you know, when we also use the server on the edge, we can throw as many GPUs as we want at it. And obviously, there's more and more frameworks coming out to allow you to use multiple GPUs and decentralized or distributed rendering. And then the system runs on a 60 gigahertz unlicensed band. And as an example, when we set it up at a conference, you know, 60 gigahertz, it's not used. It's essentially contained within the room that you're in, and that just works. You just set it up, and everything just works. So these images that you're seeing is from the Void, and an experience where you could sit inside a clearing and photorealistic world, and as you moved your hands, trees grow and plants grow around you. You feel the sun on the back of your neck or on your body because there were heat lamps. You felt the breeze blowing when trees came out of the ground. The ground rumbled. So yeah, go to the next slide. So anyway, so we did this in Santa Clara last month, and it was in a small ballroom, so we only did 6 concurrent users at the same time, but 4 AR, 2 VR users, and it was extremely good. And it really reminded me of a first demo that I had with the HTC Vive a long time ago. And I went to their lab and walked around, and I was in a virtual environment, but every so often I was feeling heat on my back, and it was kind of weird, like took me out of the immersion. I'm like, why am I feeling heat when I'm just walking through this virtual space? And it was because there was a window and the sun was coming in the window, and I was just walking into the sunlight. But that really makes you realize that adding these other aspects massively increases the immersion. And so that's what we've done with the Void. So if you go to the next slide, I think maybe many of you know of the Void. It was a company that was building out locations in malls where you would go and you put on the virtual reality headset, the 22 pounds of equipment with the backpack, but you would wander through these amazing experiences in which there was both real life things, props in the environment that you would touch. If there was a button, you'd press the button. If there was a flame, you'd feel the heat. You could pick up guns and shoot the stormtroopers when you were in the Star Wars environment. It was very, very compelling thing, and people, really enjoyed it. And what happened with the Void is COVID came along right as they were getting ready to expand their operations. Somebody just said, "I love the Void. I wish it would be back." It's coming back. So that is what we're doing. So it actually went into I'd say hibernation during COVID. And then some of the original people have bought the assets from out of done with a bridge loan anyways. And so somebody owned the assets, they bought the assets back out. And the other thing that you'll love more is it's not so heavy because you don't have to wear the backpack. And the quality before was quality that was like video game quality, because that's all that backpack, that big backpack on your back could only deal with that. It could only give you video game quality. We can give you photorealistic quality now. So imagine those experiences that much more beautiful. You really will feel like you are walking through a movie itself. And that will be amazing, because you will also be able to interact and touch, and you will see your own body, your hands, your feet. You'll see other people around you. You'll be able to interact with them. So this is going to be super exciting. And the other thing is that we can give longer experiences now, because the experiences before, they were driven by the fact that you had this very heavy backpack on. They were driven by the fact that the power consumption was very, very high. Then you had this big, sort of block of battery that you had to carry around, and it lasted for, I don't know, 30 minutes or something like that. So here you're going to be able to have very long experiences. And so we're looking at creating much, much more interesting things. So we have a strategic partnership with Avoid for location-based entertainment and virtual reality. And that should be coming out in the next year or so. We'll be relaunching that. And so just to kind of say, there's just so many opportunities here as we are able to extend reality, as we're able to address these various applications. And things like education, there's already been studies showing that if you give people VR education, they get better grades because they retain it better. And just imagine, for access to facilities or access to the ability to travel the world. One of the things I'm hoping at some point is we'll build out systems in the gyms at various schools, and the kids will just be able to go on a field trip, or they'll be able to go and see the best physics teacher with the most incredible equipment to show off, how things actually work. So amazing. I talked about entertainment already. We have a warehouse project we're doing right now, give complete visibility within the warehouse to what's there, what's in the right place, what's in the wrong place. Done some very interesting things on telemedicine, where a expert at a remote facility can instruct a novice that's out in the field doing surgery on someone, pointing out where they need to make incisions or put tubes or do various procedures. And literally the novice can stand inside the avatar of the expert. So just follow the motions, and the expert can see in fully volumetrically captured what's going on with the patient and with the novice doctor that's out in the field. And many different applications here. We will give people superpowers. We will allow you to see through the wall on a construction site, or when you're doing maintenance after the building's been built. And so we're really just getting started with this notion of extending reality, and we hope that you will all keep inventing the virtual and augmented reality future, this extended reality future with us. So thanks very much. And I've been told I can now go to the next session. So anyways, my pleasure to talk to you today.